video was a problem, so it got disconnected too. By the way, Vedant, if you're from TFS, then TFS also I've been to. Did you get to see me at TFS?
Yes, I've seen you teaching the 12th grade batch.
Yeah, correct. So from your batch, from your school rather, how many are partake?
Um, a total of 4 or 5 students have been invited to this class.
4 or 5. And who are
Yeah.
they?
Um,
Name them.
Prisha, Prisha Shroff, Shaurya Bansal, Keshav Bala Subramaniam, and me.
Okay. And why is that they are not to be seen here?
I'm not quite sure, sir.
Okay. Among them, who was the highest scorer? Are you the one?
Yes, sir.
Okay. What is your marks, if I may ask? Would it
Uh,
be convenient? Would it be convenient for you to reveal?
yes, sir.
Oh,
In my previous test, I got 265, the current PCN test.
265.
Yeah,
And the others were lesser than you. Is it so?
yes, sir.
Okay. 265. Other being how much? Are you aware of their marks?
Um, I know Keshav got 247, sir, and I don't know about the others got in the 140 to 160 range.
Okay. Okay. So that may be the reason. So you are the highest among the ones invited, correct?
Yes, sir.
Okay. How much is yours, dear Guru?
Sir, in the latest PCM, it is currently 250, but there might be there's a math retest happening tomorrow, sir. So,
Okay. 250 as of now, right?
yes, sir.
Okay. Guru, what about you? Sorry,
Sir,
Rakshan. Rakshan, what about you?
Sir, in the previous test, I got 246, but we'll have a retest tomorrow for math.
Tomorrow.
Yes.
What went wrong?
Like there was some out of portion syllabus, so because of that, there's an inconsistency in marks.
Okay. Correct me if I'm wrong. It's the same examination, right? Through and through Neve.
yes, sir.
Yes, sir.
If that is an issue with you, it'll be the same with others.
Sir, the issue was that our maths teacher had missed out a portion because he thought it was not in portions. So we've
Your
had,
math teacher, that means it is particular to you. Is it so?
yes, sir.
Yes, sir, only our batch in TCIS. The rest of the batches actually knew the portion, like it was already taught.
Only your batch.
Yes, sir. Batch A and
Okay.
DCIS.
Only PCIS won't have such problem, right? Because what you are awaiting recollection or correct, right?
Sir, can you repeat? Wasn't
Only
clear.
you have a problem. Question remains, but your batch had a problem owing to there being some discrepancy on teacher's stake, correct?
Yes, sir.
So that you're expecting a change next time, isn't it? Right?
Change in what, sir?
Change in the marks tomorrow, you said, right?
Yes, sir.
Okay. Today, IOCM results being out, and we are being joined by Shaktam is scoring around 36. We're expecting him to be the only one cutting 4 RMO from DPS and doing both the schools. Let's see. Many congratulations to Shaktam. I think all of you can extend your wishes to him. There will be RMO examination. At the same time, Shaktam may have something to disclose about Olympiad, not Olympiad, but American competitive examination. What is it, Shaktam? There's an examination coming, so those who have not appeared as yet for IOPM or Physics Olympiad, I presume you may not be aware of Physics Olympiad. It goes by the name NSEP. Same is for chemistry, NSEC, bio, NSEB. Anyway, for you is of import NSEP and NSEC. This year is a missed opportunity. Next year, all of you should apply. You should also apply for IIPM next year. An examination which still is for you, very much open to apply, is American Mathematics Competition Examination. And you can apply for that examination. Shaktam, please update them on when is the examination to happen and what will be the last date for registration. Shaktam.
The AMC American Mathematical Competition, it's held for a lot of grades 10 and 12. It's held in two versions, so 12A and 12B. So people under grade 12 can appear for 12A and 12B both, or either of the editions of the exam. One is on 5th November, one is on 13th November. There are 25 MCQs for 75 minutes, and it's an examination of 120. It holds import when taken into consideration for profiles for foreign exams. And yeah, you can appear for the AMC exam. It has weightage when it comes to foreign applications, and it's a good exposure because it's held internationally and not just within India like IIQ.
Anything for anyone to ask? Does anyone want to ask anything? Please feel free.
What will be the portions in it? Is this general overall maths portions or JE specific?
Yes, Shaktam.
It's general mathematics portions. Like there's no other syllabus. Just like IIQM is the topics in general. This one is a little bit more algebra and number based though, and less of the actual nuances like probability and everything.
Okay.
Is it clear?
Yes, sir.
Okay. Nothing to be asked? Guru?
When's the last date to register?
That is dependent on the centers because this exam is not one which you can apply individually as such. You'll have to check if there are any centers in the. It's an online based examination, but it is through specific centers only. Uh, so you'll have to check with the different institutes if they are having it conducted through them because you will not be able to register individually for it.
Okay, thanks.
Okay. So yesterday I got you a few questions on rotational mechanics. I think you may have applied for it. Two very important questions were designed by us. One was about what will happen to the sphere. Will it slip, then leave, or will leave after a slipping? So those questions were articulated over here. And we want an answer to those questions. I also asked you to correct Arihant publication on their answer. Did you happen to check Arihant publication question of the rod one?
Yes, sir.
Have you checked for the answer, what we are getting and where have they gone wrong? Did you come up with what is to be corrected there?
Yes.
You. So please let me know of your answer and what is the answer that they have gotten. Because when I go to pick a question, you have to correct that question. You have to update Arihant on the IATA. Getting it? We are doing for a cause, for a purpose. Similarly, the question which we did in class articulate, you have to come up with an answer. I ask you about what should be the value of mu for getting established what we want. Yes, Vedant, you said something about what you got as the answer. May I ask you about it, please?
Yes, sir. I corrected it directly in the textbook itself.
What was your answer? I will write it down. And what differential you got of the answer that they have published?
Sir, I don't remember exactly where I wrote it.
Okay, no, you figure it out. YP, what is your name? What is your name, YP? YP, can you hear me? What is your name?
Yeah, sure.
Yes.
Yeah, sure.
You'll join with your cameras on today. Yes, dear, you'll join with your cameras on today and you have missed 15, 16 minutes of the class, wherein we discuss many an important issue. Don't waste time of class, respond quick. If there is any issue with camera, leave class.
My camera is not working.
If it's not there, you can leave class. Anyway, you're joining after 16 minutes. Much has taken place. Please leave. Okay. Yeah, please leave the class. Okay. Now, what we'll do is, I need to do something on center of mass today. And on center of mass, the other day we were dealing with there being a ladder, there being a man. Can you reflect on that question? Did we solve it you or have solved with some other batch? Remind me on it.
You've solved it with us.
Okay, I have solved it with you. And there was such a case wherein we got for, generally what is being thought is it will be 0, but we got to see that it is not 0, right? Can you tell
Yes.
me, is it not 0? What did I
So-
tell you on that day about why is it not 0?
So you explained that the displacement of the center of mass is a vector quantity that's replaced by displacement of all the elements in that system. And so when we use that equation, then we got the final answer.
So you got me an answer that day that will be 0, right?
Yes.
That no, it will not be 0. We cannot say that with solidarity that it will be 0. So what was that it was reasoned out on? Why can't we say with solidarity that will be 0? When we know that forces are balanced, when we know that net force is 0, right? When we know that net force is 0, then why can't we say with solidarity, why can't we cement our position on displacement will be 0?
So when the so when the man starts moving, there will be an acceleration caused by him moving. So because of that, the center of mass will have some motion, and the forces will not be balanced.
Man was moving in case of boat as well. Man was seen to be moving in case of boat as well, correct? Boatman problem, right? Can you recollect on that problem? Boatman problem, can you recollect? Man was seen to be moving over here as well, right? He made a movement from this position to this position. What there we did right unflinchingly was delta XCM will be 0. Do you remember? Can you recollect on this question? Have I taken this question?
So it's you haven't given us this question directly, but we've solved this.
It's a mechanical question, must have been taken in the class, right?
Yes, sir.
So movement was over here also taken. They say dog man or man dog boat or man boat. Actually, it is a dog boat problem. So dog has made some displacement. Dog moved over here as well. We wrote equation of XCM, and accordingly for delta XCM we mark it will be 0. Right? Can you recollect it? Yes or no? So here when we uninhibitedly did mark delta XCM 0, then what kept me from marking the same in a problem which is not in general taken in the class, which is about man moving on a ladder and counterweight being placed here. Yes.
So can you say that mg is technically an external force here, and while it's in equilibrium, that time it doesn't matter. But then when he starts moving up, it creates an acceleration in the system that causes the gravity to no longer be balanced out, and so technically there is an external force in the system.
Okay. So here lies the answer. What Vedant did say, what 002 is leaving, joining, leaving, joining. Who is that 002? 002 is me. How is leaving, joining? Okay. What was the question is, we have to be very careful on two situations. Situation number one, when there is no force in a particular direction, which is what was the case over here. There were external forces, but there was no force in which direction? X direction, correct? So there is no force in a particular direction, then we did not exercise caution. We can throw caution to wind. We know that there will be no displacement of center of mass. Rather, we refrain from saying there will be no displacement of center of mass. What we can say is there will be no change in velocity of center of mass in that direction. And if initially is 0, then we can come to the position, we can move from the position and move up to the point where we may make a statement of delta XCM being 0. That's a given. But when we encounter a situation where forces are acting, but are in what state when we get to see them? Balanced state. Forces are acting, but what state they are in when we got to see them? They are in balanced state. Then have to exercise caution. And that caution will be letting us know whether it is to be 0 or get some value. We saw departure. We saw that there was some value to it, correct? And as you have a knack of missing on important points, I will ask you to solve this problem yet again. And the problem that I have gotten on rotational mechanics, there have been 5 problems. I've not got any solution to any of them. I'll ask you to get me solution to those questions. We are moving ahead with the caution. We need not lose on what we have gotten. We need to register them. Things will keep on pouring now thick and fast because I am going to extend your classes. Once Shaktam is in, I will try to extend the number of hours and you will be getting things very thickly to you dispensed. It will be difficult for you to assimilate them all. So I'm asking you to for now conflate with what you have gotten already. Please solve this question, recollecting what the question was all about. And also make yourself aware when to say 0 and when to think twice before of stating, think twice so that you are not to second guess on it. Okay? What was the question about? I recollect. Shaktam, take note of it.
Yes, sir.
The man who is trying to move on ladder, direction not known to us. But what is known? Mass of ladder smaller. And a counterweight over here, by counterweight what I mean? Counterweight has got a net weight of man and ladder. The counterweight, if I write by MC, it is capital M plus small. This is what being given to you. Then they made a statement about displacement of man. Man is getting displaced. What is the displacement that the man undergoes? Man undergoes the displacement of L. What is the displacement that man undergoes? He undergoes displacement of L. Now it's not given to you L up, L down, L horizontal, or the combination of horizontal and L. Nothing being given to you. Just given that L is the displacement. L is the displacement of man. So I do write displacement of man with respect to ladder. L is the displacement of man, capital M, with respect to ladder, small m. Clear?
Yes, sir.
What was asked in this is, what will be displacement of center of mass? What will be displacement of center of mass? Right? What will be displacement of center of mass? Center of mass of which system? Center of mass of which system? Center of mass of system comprising of ladder, small m, ladder, small m, man, capital M, and the counterweight, counterweight. Clear? What will it be? I ask you to recollect on process. Whenever is asked a question on center of mass, and follow this suit, please. Draw an algorithm, a flow chart, which can apply to all the questions. Whenever is a question on center of mass, what we have to do, we have to write equation of center of mass. What into the of that or what percent that is what the big and into
You,
capital small is a small to the Small time. See, right? Am I audible? Yeah, I'm back. Is it okay? Am I audible?
Yes.
Yes, sir, it's better now.
I presume the recording is on, right? Is it on?
Yes, sir, it's on.
So here what I'm to do is I'm to ask you what will be delta R capital M. What will be displacement of man? You need to remember these displacement are read from where? May I ask you from where I'm reading these displacements?
So for ground frame,
From ground frame. So what is displacement of man as seen from ground frame? What can be it broken into?
L vector plus
It can be broken vectorially into displacement of man with respect to ladder and ladder with respect to earth, correct?
yeah,
So displacement of man with respect to ladder and ladder with respect to earth. Man with respect to ladder is L vector and ladder with respect to earth. What we have to take is whatever you deem fit, you can mark it that way. Man with respect to ladder, I write it over here. Displacement of man with respect to earth. This is what it denotes. Which will be displacement of man with respect to ladder. That being as given to us, correct? Correct, Saktam? Displacement of man with respect to ladder. Is it correct, Saktam?
Yes, sir.
And to this, what will I add? To this, what will I add to get displacement of man with respect to earth?
Displacement of ladder with respect to earth.
Yes. Plus displacement of ladder with respect to earth, which I mark as delta Rm. So delta R small. Delta Rm I'll leave as it is, I'll not change. I seek someone to tell me
So we can write it as y.
delta Rc.
so it'll be same in magnitude and opposite in direction because of the string constraint.
Very good. It will be same as the magnitude of displacement of ladder, magnitude wise. They'll be same, but opposite in direction, right, Shaktam?
Yes, sir.
So delta RC, Shaktam, delta RC can be replaced by negative of delta RM, right?
Yes, sir.
We'll place these values, we'll get delta RCM. Please do the needful, class. Do the needful. What did we get as final answer?
So we get capital M L vector into L vector by 2 time by the total weight of the system, which is 2 times capital M plus small m.
Okay, this is what we get, right? And this is what we saw the other day, correct?
Yes, sir.
Okay. Now, quickly, as we are dealing with the center of mass, I'm raising this quick. I'll get into what we did see the other day, and that is the scooped out part and all. So tell me if I'm scooping out something must be known to you, mechanical questions. So I'll not indulge, I'll just ask. This is a disk of which we are removing certain part to this part. Where will lie center of mass of the remaining?
So on the x-axis, positive x-axis.
On the positive x-axis, where on the positive x-axis? If total mass is m, then what we have removed is m by 8, correct?
Yes.
So where will fall center of mass? These are routine questions, please. Commit the answer to memory.
So is that you said it's a disk, but
This, correct, the disk, Vedant. You're right.
so won't m by 8 be if it was a sphere?
M by 8 will be for the
Sphere.
okay. Yes, sphere to begin with. Fine. Take this sphere, and then tell me where will lie. Yes, M by 8 is for sphere. You're absolutely right. Good. Take me then to the conclusion. Where will it fall? Again, this is also a routine one. Should be there with you. Shaktam, where will it fall?
On the right hand side.
Right hand side is known. It's obvious. That is no rocket science. Where will it fall? Where on right hand side? What exactly is the position? That position should be committed to memory.
So is it r by 18 towards the right?
How much?
R by 18.
No, I don't think so. Please
So
check the
is it
calculator. R by?
R by 6 to the positive x-axis from center?
I have two answers with me. One is R by 6. The other is R by 14. Pick on the correct.
It's R by 6.
R by 6, Aktam, are you sure for the disk or sphere? What did you say for? Which one did you answer for? Disk or sphere, Shaktam?
Sphere.
Sphere. R by 6.
6.
Vedant, get the answer quickly.
So I answered for disk and I got R by 6.
R by 6 for disk. Shaktam is saying R by 6 for sphere. So there is a contradiction met.
Sir, I've gotten using for
M by
disk.
8 will be for sphere. And again, this is no rocket science. M is what to us? Rho into 4 by 3 pi r cube. And here what we have is 4 by 3 pi r by 2 cube, which is 4 by 3 pi r cube by 8. If you multiply it with rho, this will get me m by 8. So this data that I have gotten is for sphere. Okay? If you're using this data, then you are answering for sphere. Check if you have used this and then got answer, you have answered for sphere. So what is
So
the
I
answer?
tried
for
again and I got r by 14 towards the right.
R by
14.
for which case?
Sphere only, not considered sphere.
So remember class, please the answer. Aktam, Remember the answer. You need to commit few questions because they will not ask you on these questions. They will be presuming you're aware of it and will go further on ask. For example, the case wherein we ask for what will be the force on the part falling on table. And what we got to the conclusion? Double of the weight collected on table. Have you taken that question?
So you're talking about the chain question, whether there was a chain falling through.
Question.
Yeah,
In
okay.
question, we prove that whatever weight is collected on table, force experience will be double the force on the striking part or on table, right? They will ask you to plot for it. They'll get you a plot. They'll get you 4 plots. Click on the correct plot. So the prerequisite will be question being solved by you. That is what they apprehend. That is their comprehension. That is they comprehend. Similarly, here will not be asked of you. Where will it be? They will go further on us. Getting it? So preparing answers is what is coming.
Yes.
Had it not been the case, I would not taken this because these are routine questions. Please commit it to your memory. For spare, how much we got?
R by 14.
R by 14. For disk, how much we'll be getting?
R by 6.
R by 6. For cone, what we get? Center of mass position. Solid
So if
state.
it's h by 4 from the base,
H by 4. Hollow.
h by 3.
Can you prove this?
Yeah, we can take it as individual disks, and then when we integrate it, it will go. The limits are the ones that differentiate from a hemisphere.
So
And then
if I have for why didn't you suggest Vedant to take triangles? If I take triangles and try to make a cone out of it, right triangle, will it not be possible to form cone?
it will be.
It'll be, right? So why am I suggesting triangle?
I think since it depends on the type of triangle as well. Like it's usually the centroid of such a triangle. So
Right triangle. I would extract right triangles and get a cone formed. See where from I'm coming, I'll let you know. If I'm to calculate for disk, semicircular disk, one of the ways, as you suggested, I take plates, right? Take thickness, solve it. The other way is I make good of my previous knowledge. And what I do, I take a ring. Correct?
yes,
You take a ring of certain thickness. You will see in the books, they take a ring of certain thickness. And accordingly, we know for the ring, we will stack them. If you stack one ring thickness on the other ring, you'll get to form a disk. So that is one process. The other process, what did Vedant suggest? I go generally in class. We take a disk of certain thickness and solve it. So there are two processes. Same is for the other case. I'm not going there. I'll take that later. But these processes being there. Now here I asked Vedant. Vedant said that I'll be taking a disk. I'm good with it. It is similar to this one, correct? Then I asked, okay, here we stacked rings of certain thickness, semicircular arc of certain thickness. Here, Is it not possible to form this structure by stacking, not stacking exactly, by placing side by side right triangle?
Yes.
And if it's possible, Vedant, then can I go with that and see and to get same answer or different?
Yes, sir. Because it's when I derived the cone thing on my own, I figure it was easier for me to imagine the per unit density and when it was stacked up as discs.
Now, Vedant, if you tried this,
Uh,
then you will answer straight no of that.
what's it?
Then you would have answered straight no to my question. You cannot.
The discs method.
You cannot form a cone by taking right triangle and placing one after the other. Not possible.
Yes, sir, I was explaining for the discs method, like the way I did it.
Part of the eventual will be out. Why? Because at center, mass is getting additionally added. The repetition at the center.
Yes.
You cannot form a cone by stacking right triangle. Not possible by placing them side by side. Certain part will be out. Mass additionally is getting added at the axis. Getting it?
Yes, sir.
Same is the case for solid hemisphere. We cannot form. Not be possible. If I ask you a question, okay, I got semi-hemisphere. Can I get a hemisphere, solid hemisphere, by stacking discs?
Yes, sir.
Semi-disc? Think about it. Think about it. Think about it. Think about it. Think about it.
Yeah, with individual discs, it should work, sir.
Question. Can I get a solid hemisphere by stacking or keeping a semicircular disc,
No,
one after the other? Can I form?
no.
No, sir.
So that the answer is again
Sir, but can't you rotate one semicircular disc and get the whole hemisphere?
do it. Do it. That is akin to saying what I did just now. That is, can I place many discs and get hemisphere? Think about it.
So, is there any way that we can derive it by this way, but then account for the extra mass that's gathering at the center?
A good question would have been, is it possible to take a structure, stack it, get a hemisphere, solid hemisphere?
So, hemispherical shells, maybe?
Is there
Hemispherical shells, like stacking one
hemispherical?
shell.
So there you'll have to take some thickness,
Yeah.
right? You can take some thickness, and that thickness should be incorporated. You may get, right? So it is
Yes.
about hemisphere taken, shell taken with certain thickness, and then you be very cautious. Very cautious. Why I'm saying so to be, I should be cautious. You need to be very careful on what will be thickness of it and what will be radius of it. What will be thickness of it? What will be radius of it?
Yeah, we can take one hemispherical shell at a specific distance space. We can say small r, and then when we can take the thickness of it as dr, and then we can just find the area of it and multiply it by dr to find the technical volume of it. And then using that and the density that we found, we can find the center of mass for that specific hemispherical shell, and then we can integrate it from the 0 to capital R to get the
Yeah.
Right.
Lydia, you are taking a sphere, hemisphere, shell. You cannot take radius as small r. You'll have to take radius. You have to take a radius of it, expanse of it. From where to where will you be taking? What you suggested was, I'll take this, and then I'll take small one. This way, right?
yes,
The thickness of it will be dr, right?
yeah,
So radius is r. This, and then the other one, and then the other one, and then the other one, right?
yes.
So where will lie the center of it? That is known to you.
The for the hollow hemisphere,
Of this one, r by 2. If this is of x radius, r by 2.
yeah,
So one after the other, right?
no, so for the individual shell, won't it be 2r by pi?
Which one? Individual ones.
Yeah,
This
like for the smaller shell, it will be 2r by pi, right?
r by 2, right?
Right. So it's-
Right? The other process can be you take a disc of certain thickness, and radius same as that of this sphere. Getting it? You take a disc of certain thickness and radius same as that of this one. Okay? Think on that perspective as well. So I'm getting you few. One is the organic, how to find known to us that we are good with. Then is what can we ideate based on what we have learned before of these structures. How can we incorporate them? Okay, if I am to calculate for this, then I am suggesting take ring. Similarly, if I am to calculate for shell, what will you ask me to take?
ring,
Shell, what shall I take?
ring, like one ring and then stacking rings on top of each other.
Well, I have taken ring, fine. How will I write area of that ring?
2 pi r dot dr, like multiplying one dimension into the other.
Aha, dr. R, which R?
For the individual thing, for the individual ring that we choose.
So that you can take dr for shell. Because there is no mass inside.
Oh yeah, not dr. Sorry, we can do it with d theta, where we choose one individual ring and then use that to find the relation between.
Every part, every arc should be of same radius as that of shell. There's a difference over here. Here it was easy, accepted it. Why? Because mass is everywhere. When you are doing it for a hollow shell or hollow hemisphere, right? Then what will you take? You suggested you will take a ring, taken ring. But that ring cannot have any radius other than that of the shell.
So I was thinking that instead of integrating it with dr, we could integrate as theta, like from 0 to pi by 2. And at an individual theta, we can find our sine theta as that small radius. And using that, we can have the radius of the ring. So we can find the circumference of that ring and multiply it with r d theta. So
That RD theta I'm good with. RD theta I'm taking. That is capital R. You're talking of the hemisphere R.
yeah,
When you are taking ring, when you are taking arc, semicircular arc, you have taken semicircular arc, correct? As the building module, yes or no? That semicircular arc should have the same radius as that of the hemisphere, yes or no?
yes.
That radius you will have to relate in terms of theta with hemispheres. Correct? I cannot take a radius to be varying in this case.
We can take theta to be varying.
So theta is to be factored in and accordingly integrate. So think from that perspective. One, of course, is what we know organically. The other is how you will make good of the previous. Okay?
So what exactly do we have to do?
We have to think of incorporating ring for disk. Then for hemisphere, you will incorporate the ring arc again. For this one, you have already suggested what to incorporate, solid one. Okay. For cone, what you should do, what incorporation will help. Because the triangle didn't help.
So
Okay.
this,
Cone, what will help? You'll get to know. You'll let me know what will help there. Then you'll have to also let me know that in parallel axis theorem, why should pass? Are you aware of it?
so your voice cut out in the middle. Could you repeat that?
Parallel axis theorem, are you aware of it?
Yes, sir.
When do we apply parallel axis theorem?
So in 2D and 3D objects, relative to the center of mass, we can, if we have to make an axis, then we can use the distance between the axis, parallel distance between the axis and the center of mass's axis to find out the moment of inertia.
This is given to us, Vedant, that this is the case, find moment of inertia about this axis. And it's given to you that about this axis, moment of inertia is I1. And this distance is R. Right? This is a solid hemisphere. Or as we just call hemisphere. And can we use the theorem?
No, sir, because it has to pass through the center of mass, the initial axis.
Which you have to.
You can still use it, right?
Why is that? One axis should pass through center of mass. Okay? Have you been shown this? Or have been asked to commit to it?
Yeah, you asked us to revert back to you on this.
Revert, only revert, not revert back.
Yeah.
I asked you to revert on this. I asked you, I'm asking about what happened in class. Were you shown?
No.
Okay. So you will justify why so. In class, you were asked to commit to memory. Were they asked by teacher to commit to memory?
What's it?
For this parallel axis theorem, one will pass through center of mass. From where are you getting this?
You explained the I prime, sir. Like,
Explain. That means before my explanation was not known to you person.
yeah.
Okay, fine. In that case, I'm held guilty of not showing it to you at that time. I will show it to you. Try on your own. If it's known to you, if you are able to get to it, good. If you're not, then we'll take it up. Fine? We'll show why is it so. And also we'll show that how can we, and that'll be a new to the class, new to any class, I would say, how can we calculate moment of inertia for any regular shaped body about any axis, wherever the axis is. There'll be a formula derived, and with the help of that formula, what we can do, we can calculate moment of inertia for any body, any regular shaped body about any axis. You don't have to do a thing, you have to just apply that formula. But you need to know from where we are coming, so we'll be deriving that formula. Okay? That formula we will not get derived anywhere. So we'll be doing that. I need to ask Shaktam about his convenient time. If we can stretch today by 15 minutes, we'll be doing right away in the class. If we cannot stretch by 15 minutes, then I will position it to his availability, going to his day being today. I would ask him, is it possible to stretch by another 15 minutes, Shaktam? Shaktam, you're on mute.
Yeah, sure, we can continue.
Can we?
We can continue.
Oh, great. Then we stretch class.
Another doubt I had is for case, you gave us that formula for when friction's acting in rolling motion, that k square is equal to AB. If it is, there would be no friction acting. But what's that?
What was it? Come on.
Oh, the k square is equal to AB, where it's the
K square is equal to AB, right?
yeah. So my question is, we know that when friction won't be acting, but you said that we could also find out the direction of friction from that. And how do we do that?
Friction won't be acting, then there is no need for direction. I cannot ask you as an option will friction act or not, because that will attract your attention. So I don't write friction will act or not. I give it as none of the above or none of the preceding.
No, sir, I meant it like, can we somehow adapt that formula to also tell us the direction in which the friction will be acting during rolling motion?
Yes, that is the reaction. Friction means what? Reaction. Friction means if you have hit a billiard ball, then friction means reaction. So k square AB, if it is not acting, above of it will be in the same direction. If you're marking above, the force is above that point means friction will act on the body in which direction? Forward direction. If it's below, friction will act in the backward direction.
So is there any comparison between the value of k square itself and AB? Like if AB is lesser than k square, if AB is more than k square?
K square is equal to AB, then friction will not act at that point, right?
Yeah.
And A and B should be in the opposite direction to center of mass.
Yeah.
If it is above, it will act in the same direction as that of force. If it is below, it will act in the opposite direction as that of force. Of course, there is a relation.
Okay.
Now, to the one that I wanted to show you quickly. This is actually will not be there. So what we do is, we take any irregular shape body. Take any irregular shape body. And we want to try moment of inertia about this axis. We want to find moment of inertia about this axis. See to it. Or moment of inertia about this axis, whichever it is. First and the foremost, we define a vector which is unit. Lambda xi cap, lambda yj cap, lambda zk cap. So this is a lambda vector to us, which is unit vector. And then we go for position vector of ith particle, mass of ith particle, r of ith particle. Is it okay? R of any of the particles, ith particle. Position. And what is this vector? Lambda, a unit vector. How we define moment of inertia? Moment of inertia. What is the formula for moment of inertia? You know, mi, and which are the perpendicular distance. So I write for it differently from what I have taken over here. Ri R1I square summation. Actually, perpendicular distance. So what is over here, the perpendicular distance, if I may ask? Are we looking at your axis? This is the axis of interest, so this is the perpendicular distance.
R1 sine theta. Sorry, Ri sine theta.
R1 sine theta, right?
Yeah.
Can I then write it as mi into cross Ri Z? Any problem? This is a unit vector. This is Ri. All this get me is Ri sine theta, correct? That is
Yes.
the perpendicular distance from this axis. If I'll go for summation of this, then what is this to get me? What is this to get me? This to get me moment of inertia about which axis?
Lambda vector.
About axis lambda, right? Agreed? Agreed, all of you? So my question boils down to what will be delta cross Rx? I need to write next what will be delta cross Rx. For that I use matrix I J K. Lambda x, lambda y, lambda z. Correct? Lambda, lambda, lambda. And for this, simple. Xi, yi, zi. I'll erase it, so copy it down quickly. Take snapshot. Moment of inertia cannot be negative. This can get you negative as is mathematics. So be very careful. If it get negative, we'll change it to positive. See for itself. Shall I erase it? Pratham, getting it?
Yes, sir.
Oh. Now what we do, we calculate this quantity. What will it lead to quickly? I cap lambda y z minus lambda z y. I cap being there, I'm not taking I cap. They are all with I cap. Okay, it's done. J class. Lambda y z, lambda z y, correct? And minus k cap. What we have? Lambda x z minus lambda zx. This is j cap.
Yeah.
And it's k plus lambda x y minus lambda y x. Second class. But I don't have to use this. I have to use magnitude of this and square it. Correct?
Yes.
Magnitude of this. What will it be for me?
The square of all
Squaring
the
it.
coefficients.
Yes, absolutely. Square of this. Similarly, square of this. And a square of the last term. Which is this term. Yeah? Magnitude and a square means this term. Right?
Yes.
So what we get is mi into, now expanding it, fine? Lambda y square z I square. And I'll ask you to keep it at a place as well. Lambda y term one side. This will also get me lambda y square. So the other one, lambda y square xi square. Lambda y done. All lambda y one side. Then lambda x now. Lambda x square zi square. Okay. Next lambda x here. Plus lambda x square yi square. Okay. Next plus y done, x done. Let's shift our focus to z. Lambda z square y square. Correct? Then where lambda z next? Yeah. Lambda z square xi square. Idea? Not over as yet. The terms with 2 are also on, correct? This will get me to lambda y, lambda z, zy, correct? We are assimilating first the square term to 1 and you'll get to know why I'm doing so. Let us complete the statement mathematically. by incorporating other factors. What are they? I write over here. First one is minus of 2 lambda y lambda z z I y I. Getting it, class? Then what will I get? Next. Tell Vedant.
Minus 2 lambda x lambda z x z.
I write over here. Minus of 2 lambda x zi into lambda z xi. Next. The last term.
Lambda x lambda y x y.
Lambda x
Lambda y
lambda y
and x y.
xi yi. Right, class? It's complete
Yes.
now, right?
Yes.
Yes, sir.
Okay. Now look at it minutely. This is z, lambda y common, and this is x. If I use perpendicular axis theorem, then zi squared xi squared can be written as yi squared, correct?
So, so the body we're checking for is just a 2D body.
The body is three-dimensional body. Why or 2D? I'm using here now summation. I wanted to sum.
Okay. Yeah. Right.
If I'm using summation now, lambda y square will be out. Lambda y square out. Summation means what? Mi zi square, mi xi square, correct?
Yes.
Zi xi can be collectively written as moment of inertia about which axis?
Y-axis.
About y-axis. Because what we'll get when we sum is summation of mi zi and summation of mi xi, which will be what to us? Which will be nothing but moment of inertia over which axis? Moment of inertia y-axis. So first get me moment of inertia about y-axis. First part done. What about second part accordingly? Y x square outside. What will this get me when I sum?
X squared.
Z y. So x.
Xi squared. Yeah.
Moment of inertia about x. What about the third one? Lambda z square into what, class?
Iz.
Y x. So moment of inertia about which axis?
Z-axis.
Z. And what else will follow? What else will follow? This is done, right? I'll write it as it is. Minus of 2 yz and lambda y. Now look at this factor, please. This is important. We'll break one and follow the suit. Ci can be written as ZCM plus Zi prime. Ith as seen from any frame can be written as moment of inertia of body per se plus ith as seen from center of mass frame. Remember we did that?
Yes.
You've seen this earlier when we were relating center of mass frame with the other frame. So this can be written as ZCM plus ZI prime. What are they? ZCM means center of mass of the body. Z coordinate of center of mass of the body of the system person. And ZI prime means center of mass of the other particle as seen from center of mass frame. Correct?
Yes.
Position of the ith particle as seen from center of mass frame. This is position of the ith particle as seen from center of mass frame. Look at this. This is important. Is this clear to you, Shaktam? We saw the other day. Shaktam,
Yes, sir.
this is what to us? This is Z of ith particle as seen from any frame, which can be broken as Z of the system per se, and so that will be added Z of the ith particle as seen from center of mass frame. Now look at this. This constant, this also constant, correct? This constant, this will depend on position of the particle, okay?
Yeah.
If we have a symmetrical body, and if we do the same for these, then this, and this, they will cancel. Symmetrical means what? From center of mass, you are taking Z. And for the other particle, you are taking Z this side. Summing over, what will happen? This will get cancelled. Only for symmetrical body. That's the caveat. Similarly, when you will do for Y, when you break this will get cancelled. If you do for Z, or cancel already. If you do for X, again when you sum it over, because you have to sum over eventually on all the particles, and the body is symmetric, so this will also get cancelled. Whatever you have from center of mass position X direction, this particle is X direction, this particle. So when you sum it over with respect to center of mass, what will happen? Symmetric, it will get cancelled. Tell me yes or no?
Yes, sir.
So for symmetric body, we don't have to worry about this part. This will get cancelled. This will be carried. ZCM will not get cancelled. They are constant, correct?
Yes, sir.
So for symmetric body, what we are getting is this carried, this carried, this carried. Now from here, what will be carried? You can tell me.
Z,
Where is
C.
X? You got X. When it is this carried is going to vanish. And what was carried is this, correct? Correct? Check it out, class.
Yes.
Please do check, this is important. Similarly, what will get here? For the other one, tell me for all. Tell me for all. What did I do over here? Let me remind you. YZ. This was written as ZCM Z prime. Correct? Look over here. Look over here. Not complete. This was written as ZCM Z prime. And this will be written as
Y, C, and Y prime.
prime. So what you'll be carrying is
YCM.
into YCM, correct? From the first one. From the first one. You may ask, what about GCM into Y prime? Because when you expand, let me write down for you. When you expand, what I will get, I'm writing that down. This was GCM plus ZI prime into YCM plus YI prime, correct? We'll get four factors. One will be GCM, YCM, good. The other will be GCM, YI prime. You know that MI into YI prime summation will be 0. We have learned that, correct? MI prime 0. MI VI prime 0. MI AI prime 0. So MI into YI prime 0. Similarly, MI into ZI prime 0. Please be very careful of other factors also will be 0, but there are different reasons for it. We will get GCM, YCM, okay. What about GCM, YI prime? This will be 0 because MI, YI prime summation is 0. Then you will ask me, what about ZI prime, YCM? This will also be 0 because summation of MI, ZI prime will also be 0, correct? Then coming to what about ZI prime, YI prime? This will be 0 because we are taking symmetric. This will be 0, ZI prime, YI prime, because we are taking what body? This related to only symmetric body. Symmetric about which axis? Symmetric about center of mass. So reason for that being 0 is different from reason being other two being 0, correct? But what we are eventuating to certainly is all the three factors will be 0 for different, two being same reason and third being the reason. If at all we are keeping to what body? Symmetric body. What will be left with then? Tell me.
So lambda Z, lambda Y, ZCM, YCM.
Correct. And if we take symmetric case, please write that down. Now comes the final formula to you. Here comes the final formula to you. It is simple to remember owing to symmetry. What else? You see, all done?
Yes.
Yes, sir.
This is the formula. This is the formula. Apply for any case. I'll get you for one case. Take a cube. Take an axis which is body diagonal. Take this as your y-axis. This as your x-axis. And take the body diagonal. Apply it. Body diagonal, from anywhere to anywhere. You can take the simple one if you want it to be simpler. This is origin. This is 0, 0, 0. And this is A, comma, A, comma, A. What will be your lambda quickly? Lambda. And I
AI
have to
cap,
tell
A J cap, A K cap.
these 2 points. What will it be, lambda?
AI cap, A J cap, A K cap.
Joe, that'll be A vector. Lambda is a unit vector, dear. I told you.
So it'll be I cap by root 3 plus J cap
Lambda
by root 3.
vector.
Yes.
So what will it be? AI cap plus AJ cap plus A K cap divided by its magnitude, correct?
Yeah.
What will that get me? 1 by
Root
root
3.
3 I cap, correct?
Yeah.
Plus 1 by root 3 J cap plus 1 by root 3 K cap, correct?
Yes.
So that's known to me. What about HCM, YCM, VCM? Three
A by 2, A by 2, A by 2.
by 2, A by 2, A by 2. Okay. What about IY, IX, IZ? IX how much? IX means you are thinking of a rod. Okay, this is how we will calculate. Rod of what length? Rod of length A. And you are calculating moment of inertia from one of the edge of the rod. What is the formula for it? ML square by 3. Correct? Are you known to it?
Yeah.
Okay. Shortcut is not known, then we will be getting a no on it. You can take it this way. On the rod of length L, mass M, about an axis passing through one of its end is what to us, class? Tell me.
ML square by 3.
ML square by 3.
How? ML square by
3.
6. Over here, Ix will be what you know, which will be equal to Iy as it is a cube, which will be equal to Iz. You know what to write. Use this formula, which is there with you, and see you get the correct answer or not. Okay? You can do that. It's simple. Check quickly. What is the answer? Please don't forget to operate mod. Check what is the answer. Iy known, Ix known, everything known now, everything written over here. Let me know what you get as the answer. Square term. Here also it is symmetric, very simple to calculate.
So what will we write for Ix, Iy, Iz? Will it be MA square by 3?
Ix will be for a rod. For a rod, we take it similar to, as I told you, ml square by 3. About one of its axis, which passes through n. ml square by 3. L over here will be A. So MA square by 3.
Sir,
Yes, dear.
what will be the value? I couldn't hear you.
What is the value of?
Value. I couldn't hear it. Couldn't catch your voice.
MA square by 3.
So will we get MA square by 3 minus A square by 2?
MA square by 3
minus a square by 2.
No, I want the answer for this. IY, IX, IZ known to you, lambda Y, lambda X, lambda Z known to you, XCM, YCM, everything known to you. Place them. Let's see what are you getting the value
So
as.
with that, we're getting the same thing, but then dimensionally, -2 lambda x lambda y xcm ycm doesn't have a mass term in it.
No, there was MI, right? There
Yeah.
was MI. MI was there everywhere. Here when you sum, you'll get mass. Here you'll sum, you'll get mass. Here you'll get sum when you get mass. For Shaktam, I have not written M over here. M is being carried. This has got M because there is IY, there is IX, there is IZ. Here will be M over here, Shaktam. Here will be M over here, Shaktam. And here also there will be M. Is it okay, Shaktam?
So minus ma square by 6.
Minus,
Ma square by 6.
Yeah,
And
just
we
the
need-
mod.
correct. So what
What,
we
sir?
get is MA square by 6, right, Shaktam?
Yes, sir.
Good. And that is what is the answer. This is the formula which will get you for any symmetric body about any axis. That's the beauty of this formula. Any axis taken, you can calculate. Here the body should be symmetric. Clear? Vedant, are you there? Vedant, are you there? You're having a question about lamina. I think that has been addressed. Is it clear to you, Shaktam? How did we arrive to this formula? We can rework on it. Formula should be committed to memory, and the import of this formula should be carried. Okay?
Yes, sir.
Okay, then we keep to this. Thank you. Thank you, all of you.
Thank you, sir.
Thank you, sir.